Hey everyone, I decided to do another example, this time on determining limiting reactants. Now, we talked about limiting reactants, and I think everybody has a handful on this. If I'm trying to make two batches of chocolate chip cookies, and each batch I need 2 cups of brown sugar. And if I go into the cabinet and I find that I have 5 cups of brown sugar, I have enough. I have enough to make two batches, all right? But if I looked in that cabinet and I only had 3 cups of brown sugar, that's going to limit how many batches I can make. In that case, I can only have one. So in this case, we're going to look at this in terms of a chemical equation. And I'm going to give you two starting amounts of material. So let's say I had, let's go with two numbers here. Let's say I had 5 grams of aluminum, and I'm also giving you, let's go 10 grams, just for the heck of it, 10 grams of iron oxide. All right, and those are our starting ingredients or our reactants to make these two things. So I'm giving you these two things to start with, and I want you to tell me what we can do with it. So here's a question. If I gave you these two things as starting materials, will there be anything left over at the end of the reaction? Will there be any aluminum or any iron oxide left over? Or I could ask you, which one of these ingredients is going to be the limiting reactant? So let me write that down. So which one of these two things, 5 grams of aluminum or 10 grams of iron oxide, will be the limiting reactant? It's the same thing as saying 5 cups of chocolate chips or 3 cups of brown sugar. Which one will be the limiting reactant in making chocolate chip cookies? So how do I answer this problem? Well, uh, it's a lot of work. It turns out you need to do the stoichiometry process for both of these materials. Okay, you need to start with 5 grams of aluminum and go through the entire process. But you're also going to need to do the same thing, not at the same time, with 10 grams of iron oxide. So let me get this written in. Oh, there's a 3, and I put it over 1. So I need to do the entire stoichiometry process with both of these to figure out which one is going to be the limiting reactant. Now, you can pick a product. Pick a product. If I started with 5 grams of aluminum, how much iron could I make? If I started with 10 grams of iron oxide, how much iron could I make? Pick one product and then do the stoichiometry process. So let's do that. I'm going to set this up and then you guys should do it at the same time. Okay, so far what I've written, I've converted my 5 grams of aluminum into moles of aluminum, and I can cancel out grams of aluminum with grams of aluminum. And then I took a look at the chemical equation. I said, what's the relationship between aluminum and iron? And I found that it's 2 to 2. So now I cancel out moles of aluminum with moles of aluminum. I have to do the last step and find out how heavy 2 moles of this is going to be. Okay, so I have molar mass of iron. 1 mole of iron is 55.845 grams of iron. Now I'm going to solve 5 divided by 26.981. 2 over 2 is 1, and then multiplied by that. Okay, so using this process, if I started with 5 grams of aluminum, I could make 10.3 grams of iron. So now I need to do this entire thing again, but instead starting with iron oxide. But guess what? You get to use the same numbers in here. All right, so I'm going to do the entire process, and I want to end up with how many grams of iron could I make given a starting amount of 10 grams of iron oxide, okay? Okay, so we did a lot of work here. I went and took our 10 grams of iron oxide, I got the molar mass of iron oxide, and then I looked at the ratio. I know that there's 1 part iron oxide for every 2 parts of iron, and I had to put this in here to cancel. And then I used the molar mass of iron again. And the nice thing about this is we end up using the same numbers a lot, so you don't have to go and do a lot of other work again. So check this out. If I start with 5 grams of aluminum, I can make 10.3 grams of iron. If I start with 10 grams of iron oxide, I could theoretically make 6.99 grams of iron. So what's the problem? I don't make the same amount of iron from both. Which one can make more? All right, 5 grams of aluminum. So watch this. If I actually had a reaction where I started with 5 grams of aluminum and enough iron oxide, I can end up making 10.3 grams of iron. If I started this with 10 grams of iron oxide and enough aluminum, I can only make 6.99 grams of iron. So this is a problem. If I use these two as starting amounts of my reaction, one of them could theoretically produce more iron and one of them can't. The number that is the number that's the smallest is always going to be telling you the limiting reactant. So in this case, 10 grams of iron oxide is not enough iron oxide. This is the component that is going to limit how much iron I can actually make in this reaction. It's the limiting reactant. This is exactly the same as if I need 3 cups of brown sugar and I only have 2 cups of brown sugar. The brown sugar is what limits how many batches of chocolate chips I can make. What we're saying here is the iron oxide is limiting. The amount of iron oxide I start with is limiting how much iron I could actually make in the end. This is how we find limiting reactant. It is a lot of work. So now that you know what the limiting reactant is, now you could take your limiter and go back and find out exactly how much of the other thing you actually need. I wanted to say one more thing. In any chemical reaction, in any chemical reaction, the limiting reactant is always the one that's completely consumed in the reaction. So basically what we're saying is, if I do this reaction, every bit of the iron oxide that I have here is going to be consumed, is going to be used up. Every bit of iron oxide that I start with, all of this 10 grams of iron oxide is going to be completely consumed in the course of this chemical reaction. And what that means is I'm going to have excess aluminum. Okay? So those are two good things to know. The limiting reactant is always consumed. So let me write this down. This is the limiting reactant. Limiting reactant is always completely consumed. There's none of it left. The excess reactant is going to have, guess what? Excess material left over. So now what I could do is take my limiting reactant and actually go back and say how much aluminum will be left over. So guess what? I get to do this entire process over again. Okay, so now when I do the last part, I want to determine exactly how much of my excess reactant I have. I have to start with what I finished up with here. If I say 6.99 grams of iron is what's actually formed, and this is, by the way, this is one way you can do this. I'm just showing you an example. If I start with 6.99 grams of iron, work your way back to find exactly how many grams of aluminum you would actually need. So see if you can do this process yourself right now, okay? Okay, so watch what we just did. We took the 6.99 grams of iron, which we knew we could form. It's our limiting reactant. We said, hey, if all of this iron oxide goes to forming 6.99 grams of iron, take the iron and now make it your starting point here and go and see exactly how much aluminum we need. So at 6.99 grams of iron divided by the molar mass of iron, you convert it to moles. Looking at the ratio in the formula, 2 moles of iron for every 2 moles of aluminum. Take our moles of aluminum and convert it back to molar mass. We need 3.4 grams of aluminum. So if I started this reaction, watch this. If I started this reaction with 3.4 grams of aluminum and 10 grams of iron oxide, oh, I'm still recording. If I started this reaction with 3.4 grams of aluminum and 10 grams of iron oxide, that's all I would need. The problem is I started the reaction with 5 grams of aluminum. I only need 3.4. So now what I can do is come up and take 5 grams, subtract the 3.4 from it, and I end up with 1.6 grams of aluminum, and that is what we call excess, right? So if I did this chemical reaction and I started it with 5 grams of aluminum, 10 grams of iron oxide, every bit of the iron oxide is going to be consumed in the reaction because it's a limiting reactant. If I go back and calculate, I can find out that I only need 3.4 grams of aluminum to make the whole thing work. I actually have 5. So I'm going to have, when I'm all said and done, and I have my reaction vessel and I take a look at it, there's going to be 1.6 grams of aluminum in here. Okay, this is a limiting reactant problem. This is a lot of work. I'm not trying to sugarcoat this. You basically need to do the stoichiometry process at least 3 times. So you only get better at this with practice. Okay? Now I showed you one way to do this. There's lots of ways to solve this problem, but use my method at first, especially if you haven't done this in a while. Use my method, then we can kind of branch out and find other methods. Okay? All right, good luck people. Keep at it.